Welcome to this UASMaster video tutorial. In this video we want to show the classic orthophoto generation with UASMaster version 9.1. We did create in the previous videos a digital terrain model using the feature-based matching and least square matching functionalities from the surface generation. And afterwards, we did edit the point cloud to get from this digital terrain model a specific height accuracy. After the editing is completed, we want now to create orthophotos, and today we will run the classic orthophoto generation, which will auto-rectify every single photo and create an orthophoto from it in our temporary file structure. And then when we run the classic orthophoto, I can do it here during we speak. So here I choose from the method the classic orthophoto. I already created here a strategy. By default, normally you have here a different setting. So you can here create a new one, and then I called it classic orthophoto, and then I switched here classic orthophoto, and I defined my ground sample distance, the pixel size, to 5 centimeter, because my data we have looked yesterday at it has every 4.6 centimeters an orthophoto pixel, and therefore we want to stay within our range, which is then 5 centimeter. You should not generate orthophotos for this project below 4.6 centimeters, because then you will extrapolate the orthophoto pixels. And then I can here start the process. I can save it. Please close all existing files. If you have some files opened from the temporary folder, because we will always check if the temporary folder is accessed or not, and if not, then we delete it and we rewrite all the new temporary files into it. Therefore, if you want to store your report file, then you should now move it out of your temporary folder, because after the orthophoto generation, then this log file, for example, for our point cloud generation also will miss there. So I will use all the informations and start the orthophoto generation. So after the orthophoto process has auto-rectified all the 43 photos, then UASMaster runs some automatic radiometric and color corrections between these orthophotos, and then it will write finally the mosaic for the project into your project folder. So the mosaic is not stored in the temporary file structure, but it's written to the project folder. And after the mosaic is then finished, we can then review the mosaic, because the mosaic is automatically added to the UASMaster project. And then we can overlay our digital terrain model one more time, and we can see if the auto rectification was done correctly in these areas, or if there are some corrections needed. And this is also possible. We can rerun some corrections on our digital terrain model, and then we can calculate a small patch, a mosaic patch, and this patch can then be added to our already existing mosaic for optimization. And this would then also be our final deliverable. So we have then our mosaic with a specific ground sample distance created from our edited point cloud, and this then you can provide to your customer. So the mosaiking here, as I mentioned, has finished the auto rectification for the photos and is now currently running the mosaiking with the radiometric correction and color correction. I will speed up now the video till the mosaic is finished, and then we continue. Here we go, the project is done. We see here at the final stage that the project output is done. So we can close here the window. If you would have warnings or errors, you have here an error or warning tab where it's mentioned what the issue is. And then we can load again our digital terrain model. And when we load the digital terrain model, we can here on the left side see now in the Ortho tab that the mosaic was automatically placed into our project file. We can double click here the display icon, and then we can here remove the points if we want, and also the footprints, and then we just see our mosaic here, and we can then zoom in, take a look at the data itself. And as mentioned, we can still look at the point clouds, also at the contour lines, and so we can see also where our control points are displayed, if they are correctly in position here on our control points, and also if there are some misplacements in our orthophoto itself in the mosaic, and then we could here do some corrections. And also, as mentioned, we want to take a look at our temporary folder. So when we look here at the temporary folder in the UASMaster engine temp, we see here in between the temporary files, and here in the rectify folder we see now our ortho photos for each single photo. I just here want to show here when we take the orthophoto, then we have here, this is the orthophoto from the photo 3782. So if we look at 3782, you see this is the complete photo, and from this complete photo then this portion was here extracted. So we see that not the whole image is ortho rectified, but the center part of the orthophoto, which is nice, from the aerial image, which is nice because then we have less occlusion, less buildings are bending into the areas or trees. We are looking more from a center part of view into this location, and this gives us then also better looking orthophotos. And also additionally, the mosaic was then color corrected, so allowing to avoid the difference between radiometry in these parts. And if we want to take a look here at this information, then we can look here also at the auto seam information, which is then in the mosaic folder. This auto seam DXF shows us where the seam line was processed. We can load this also into our US edit part. We can go here and take this location and import here some vector data, and then we go directly to this folder, load the auto seam, then we select these two informations and add them as break lines, and then we can now see where these single orthophotos were extracted, and if there are issues in these areas, if we would see here a color difference going from one to the next photo. Last but not least, again, we will just go here to the road. Here I have, for example, the seam line that was having generated here a geometric distortion going from one photo to the other, mainly because I have to remove again my seam lines here. So we just here go to the terrain, and here don't use the break lines. And when we look here at our postal parts here in the profile view, we can see that here the street is not going straight, but we have here some undulation in this part, and so we could here fix these parts. We could place here the data on the ground and then regenerate this area here, and I will just quickly go through this process and then not explain it, just that you see how I correct it. I did some small correction here to have the data on the ground in this part here, and now I will run from the edit mosaic the patch correction. So I will here define a patch here where my misplaced orthophoto is. And so I will just place it here also within the trees, just to have a smooth overlay again from it. And then this is now my new patch that will be created. Hopefully then avoiding here this misplacements, and then I say to create this patch here. It will automatically here use the same pixel size from my original mosaic, and then it will run for this area mosaic generation, a patch mosaic generation. Then when the patch mosaic is created, it will also be added to our project. So I will then open up afterwards again the Ortho tab, and in the Ortho tab you will see then the patch. And we can switch between the patch and the mosaic. We can see if this patch was now representing this area in a better way, and if we agree that this is our better solution, because of better radiometry or better geometry or both of them, then we can say, okay, let's add this patch to the mosaic. And this is exactly what we will now do. I will here close this part. We will again zoom to this area here. I open the Ortho tab. We see now here is the patch view. I activate the patch, and then we see in the patch now this part is correctly done. Of course, what I did not do is I did not continue everywhere, so I should have done the whole correction along the whole street, but I think you get the idea. So here before and here after, and so we can then add this patch into our mosaic. And to do this we use the merge patch functionality. So I will then place this into our mosaic, and then we see now this is now our new mosaic. And of course this is a nice tool to make some optimization and to deliver a high quality mosaic finally to your customer. Going back to the output folder, so when I go here in this folder, we see here is the mosaic.tif, which is then our final deliverable from the classic orthophoto generation. I hope this helped you to create with the feature-based matching, least square matching, a good digital terrain model, to edit your terrain model, and to deliver a good mosaic as a final product. Thank you very much for watching this video tutorial, and have a nice day. Goodbye.